The 52nd episode in an ongoing series of eruptions, Kilauea Volcano produced a giant lava fountain, a cloud of volcanic ash that rose tens of thousands of feet into the atmosphere, and millions of cubic meters of lava flooded the floor of Halema'uma'u Crater in just a few hours. The officials said, this eruption, like all recent eruptions, is expected to be confined to the Halema'uma'u Crater within Hawaii Volcano National Park. Volcanic gas that's released during eruptions can impact people downwind, particularly those with respiratory issues or other sensitive populations. Scientists are continuously monitoring any changes occurring beneath the volcano. Monitoring instruments indicate that Kilauea's magma system remains highly active, requiring 24-hour surveillance to detect any further changes in activity. According to the United States Geological Survey, USGS, the 52nd episode began on Tuesday at 7:10 p.m. Hawaii time, when lava began erupting from the northern vent within Halema'uma'u Crater. Shortly thereafter, the lava flow turned into a giant fountain that reached a height of approximately 500 feet, about 152 meters. Simultaneously, a column of volcanic gas, steam, and ash rose to 19,000 feet above sea level, or about 5.8 kilometers, creating a dramatic spectacle visible from various areas of Hawaii Volcano's National Park. The eruption continued unabated for more than 7 hours before finally ending at 2:36 a.m. local time on Wednesday. During its most intense phase, around 9:15 p.m. local time, scientists recorded a lava flow rate of approximately 350 cubic yards per second. This volume demonstrates the enormous pressure of the magma released from beneath the Earth's surface. Overall, the USGS estimates that approximately 6.1 million cubic meters of lava were ejected during this episode. This amount was enough to cover nearly 50% of the floor of Halema'uma'u Crater, reshaping Kilauea's summit landscape overnight. Despite the enormous volume of lava, the entire flow remains within Halema'uma'u Crater and a portion of the southwest portion of Kaluapele, the main caldera at Kilauea's summit. No lava flows threaten residential areas. Scientists observed an interesting phenomenon for approximately 4 minutes. Instead of simply emitting lava, the northern vent spewed a jet of volcanic gas accompanied by flames emerging from the crater. Meanwhile, the southern vent, which had not emitted lava throughout the episode, also began emitting flames shortly before activity ceased completely. This phenomenon indicates that the magma conduit system was still experiencing pressure changes until the final seconds of the eruption. The USGS reported the distribution of fine volcanic ash in several public areas within Hawaii Volcano's National Park. However, no ejected incandescent rocks or large magma fragments reached populated areas. This indicates that despite the eruption's intensity, its impact remains concentrated at the volcano's summit. Volcanologists maintain intensive monitoring using a network of seismometers, ground deformation sensors, thermal cameras, volcanic gas meters, and satellite systems. This equipment is designed to detect even the slightest changes beneath Kilauea's surface, including the movement of new magma. However, changes in pressure within the magma chamber, including ground deformation, often provide early clues before the next eruption. Monitoring data such as volcanic earthquakes, inflation, or swelling of the volcano's body, and changes in gas emissions are key indicators for scientists in predicting the development of Kilauea's activity. The USGS confirms that Kilauea's activity over the past few months has been episodic, meaning periods of eruptions separated by quiet periods. Therefore, scientists are closely monitoring any changes occurring beneath the volcano. Although the 50-second episode has concluded, experts confirm that the end of one episode does not mean the volcanic system has returned to normal. In fact, after each eruption, new magma can accumulate beneath the volcano's summit, increasing pressure before being released in the next episode. As long as Kilauea continues to show signs of inflation, volcanic earthquake activity, and changes in gas emissions, intensive monitoring will continue. Hawaii's most active volcano remains one of the world's most important natural laboratories for understanding how magma moves, builds pressure, and ultimately triggers subsequent eruptions. This period of frequent activity at Kilauea is being driven by magma chambers that are quickly refilling within the volcano. These short eruptions have not been strong enough to dramatically change the pressure in these chambers, which have reached something of an equilibrium, the USGS said.